Question is minimum pair removal to sort array. So given an array nums, you can perform the following operation any number of times. So select the adjacent pair with the minimum sum in the nums. We can select adjacent pairs like 5 2 2 3 3 1. And if multiple such pair exist, choose the leftmost one. Okay, and replace the pair with their sum and return the minimum number of operation needed to make the array non-decreasing or in the increasing order. So we have to make this array nums in the increasing order, and we have to return the number of operations in which we can do so. So this is the same question as the previous one. Difference is just like previous it was easy, today it is hard because of the constraints we have been given. So we can not use brute force here, so let's try to use linked list here. So suppose this is the nums array we have given, so we will create it in this form. Linked list 1, we will create it in the linked list. So 5, then 2, then 3, then 1 in this order. So first let's create a different class for the node. So let's create node class node, defining it. First we will take the value, and second the left thing. We will take this left to track the which is the leftmost minimum sum. So we can simply set the value now. Self dot value is equal to value self dot left is equal to left, and we are creating doubly linked list here. So self dot previous, let's initially set it to none. Similarly self dot next, initially set this to none. Okay, so now let's create the so now let's create an array pq. We will also use a heap queue to keep track of the minimum sum we have got so far. So for that we will have to import the heap queue to import heap queue. Now let's create the head of our doubly linked list. So head is equal to nothing but the node element at the index 0 position, and the left thing will be the index of that particular thing. So currently the index is 0. Now we can create a new pointer. We can mark it as the head. Current is equal to head. Now let's create a merged array which will keep track of is the element at particular index is merged or not. So then let's set value to false initially. Okay, now let's create a decreasing count variable which will keep the track of how many wrong positions are there of the elements. Like nums of I minus 1 is greater than the nums of I, that means they are in the decreasing order, not in the increasing order. So let's initially put that to 0, and count all the operations we can put 0. Now we can simply go and create our doubly linked list. So for I in range 1 to lane of nums, we are going for 1 because initially we have created for the 0 head. So simply create a new node is equal to node of what is the value of this, nothing but the nums at that particular I, and left will be nothing but the I, nothing but the I itself. Now simply go current dot next. Current is this one correctly head, so current dot next is equal to new node, and new node which we have created just now dot previous is equal to, you can simply mark it is equal to current. And now we can simply push this thing in the our heap so that it can store the minimum adjacent element sum at the top. So heap q dot heap push in which array this pq which we have created into, we will pass the class here which we will create just now, pq item, in which we can in which we can pass the first value as the current. We pass the adjacent one current, then new node, and third thing we will pass the cost, which is the sum of the current dot value and new node dot value. So now let's try to create this pq item class. So simply class here, create class pq item, here. Then you can simply say init function, which will take argument self, then first element, then second adjacent element, and then the cost, which is the sum of both. So set them first, self dot first is equal to first, self dot second is equal to second, and self dot cost is equal to cost. Now we can create another function which will keep track of which will be sorted first, which will be the minimum. So let's create a lt one, and which will take self and the other as the input. And if cost of both is same, if self dot cost is equal to other dot cost, so we will simply sort in the order of the left index. That's why we have created this left pointer. So self dot first dot left is less than other dot first dot left, and if both are not equal, so simply we will sort them on the basis of the cost. The minimum cost will come up, so return self dot cost other dot cost. So we have created this our pq item class. So heapq dot heap push is done here. Now we have to also count the how many decreasing counter there, means they are in the wrong order. So simply if not outer of loop, it will be inside. So if nums of I minus 1 is greater than nums of I, okay, so simply we will increment the decreasing count plus is equal to 1, and set current is equal to next node, So now we will simply go through the loop until our decreasing count reduces to 0. So while decreasing count is greater than 0, we will simply pop the heap. So item is equal to heap q dot heap pop, item is equal to heap q dot heap pop from the pq. Now we can simply assign first comma second comma cost is equal to, simply get the element from the item dot first. We have created the class here, item dot first comma item dot second and item dot cost. So we have got this thing. Now suppose if merged, which is merge first dot left, if it is already merged, or if second dot left is already merged, or the cost of both is not equal to the sum of both is not equal to the cost. So first dot value plus second dot value is not equal to the cost. In that case we can simply continue as this is already merged or cost is not equal to that. Else our operation will increase to 1, and if it was the case like first dot value was greater than second dot value, that means it was in the wrong order. Now we are going to merge that, so our count will decrease. Decreasing count minus is equal to 1. Okay, so this now we can simply go, we have to replace that second one, so we can simply say previous node is equal to, as we are merging the first and the second one, so previous node is equal to first dot previous, and next node will be now second dot next. Node will be second dot next, and then we can create a pointer between them, so first dot next is equal to next node. We are skipping that second one. Now check if next node exists. If next node, then next node dot previous will be equal to the first, as first will contain the sum of both first and the second. Now check if there is previous node, okay, and if previous node was, suppose initially it was greater than the first dot previous node dot value, previous node dot value was greater than the first dot value, means it was in the wrong order, and now the previous node dot value is less than the cost. Yes, now cost is the sum of both first and second, so if now previous node dot value is less than equal to cost, means now it is in the right order, so we can simply decrement the decreasing count. Decreasing count minus is equal to 1. If suppose initially it was previous node dot value, previous node dot value was less than equal to first dot value, means it was in the correct order, but now the previous node dot value is greater than the cost, means we have got one more wrong order, so we will increase decreasing count, increase the decreasing count plus is equal to 1, and now we can simply push this to heap, so heap q dot heap push in which array, pq, and what to push, this class pq item, and what will be our first element, this previous node and the first, previous node and the first, and the cost will be sum of the previous node dot value, and the first has become the first plus second. Okay, so previous node dot value plus the cost. Similarly, we will check for the next node. If next dot node exists, so if second, typo mistake, so if second dot value was initially greater than next node dot value, but now cost is less than equal to next node dot value, so now it is in the correct order. We can simply decrement the decreasing count minus is equal to 1. If the same case second dot value was initially less than or equal to the next node dot value, and now cost has got more than the next node dot value, so simply you can implement the decreasing count plus is equal to 1, and similarly just push it in the heap. So heap q dot heap push, in which array to push, pq, and what to push, the pq item, and which will be the first node to be this first, then another will be the next node, and what will be their sum, cost plus, as first plus second and become the cost, and next node dot value, and finally we can set first dot value is equal to cost, as it has become the sum of first and the second, and simply set merged of second dot left is equal to 2, means this has been merged already, and finally we can simply return the count, the total operation taken. Now let's try to run this test cases. Yeah, so we are getting some error, name next node is not defined, which line, current is equal to next node, I think it should be new node, as we have created the new node here, right? Current should be equal to, this is typo mistake, current should be equal to new node. Let's try to run now. Okay, again a typo mistake, merged is written 1 hour extra is here, correct? Yeah, let's try to run now, hope it passes. Not again, now we have made the mistake. This hour comes extra every time, merged. Now try to run this. Okay, so test cases have been passed. Let's try to submit our code now and see if this works. Name next node is not defined, again where the error has reflected. Line 118, if second dot value, this hyphen, somewhere not the hyphen. Its hyphen is correct, this is wrong. If next node, okay, next node I have written correctly here correct, here correct, yeah. Next node correct, let's try first. Use this test case here only first. Yeah, now try to run this. So many typo mistakes. Now try to submit this. Yeah, so our code has passed successfully. Thank you.